So here we go. We have Pure 1 Chapter 1 Algebraic expressions. Now we have different success criteria during the lesson and we're going to be able to make sure that we can do all of this. As I said, this is an extension on GCSE, so we will go through it. If you are comfortable with some of the questions, please make your way through it. In this chapter, we're going to be looking at basic indice laws, expanding brackets, factorising quadratics and cubics, fractional and negative powers, and surds. Okay, if you do feel comfortable with this, you can skip ahead to the questions and I'll show you what questions you will be doing. So, very quickly, our index laws. So we're just going to simplify. So here we go. We're going to start with when we have 2, so we have a cubed to the power of 2. We're going to multiply the powers. So we're going to get a to the power of 6 times 2a squared. Now, we are going to multiply the numbers together, which is 2, and then we're going to add the powers, a to the power of a. So then the next part of the question, we have simplify 4x cubed y all cubed. Now, when we're simplifying and we have a number, which is then in a bracket and is then cubed, we have to cube this number 4. So 4 cubed is 4 times 4 times 4, which is 64. Again, x cubed to the power of 3. We multiply the power, so I'm going to get x to the power of 9, y to the power of 3. For the next example, we need to simplify. So we need to expand out the brackets and then simplify. So I'm going to start with the first bracket. 2x squared times 3 is 6x squared. 2x squared times positive 5x is 10x cubed. And then I have minus x times 4 is minus 4x. And I have minus times minus x squared is positive x squared. Please watch out for this negative x here, so that when you make sure that when you multiply, you bring that over. We can then see if we can simplify. What like terms do we have? Well, 6x squared and plus x squared is a like term. All the other terms are different. So we're going to have 10x cubed. 6x squared plus x squared is plus 7x squared minus 4x. And then we have simplified. And then for the last question, we have a fraction. Now, when we are simplifying fractions, as long as they all have a common multiple, we can start cancelling. As you can see here, all of them have an x. So I could rewrite x cubed as x times x squared minus 2 lots of x over 3 lots of x lots of x. I do not expect you to write it out like this, but what I just wanted to show you is that all of them have a common factor of x. So we can cancel an x from each statement. So then my answer is going to be, I can cancel an x from each one. So I'm going to have x squared minus 2 over 3x. Now, I cannot simplify this anymore because they now do not have another common factor. And, even though this x squared and this 3x has a common factor of x, the minus 2 does not. And if we're cancelling from the numerator, we have to cancel from every term in the numerator as well as the denominator. So what I would like you to do now is to test your understanding. You have 4 questions to do. Can you please give them a go? So for question 1, we're simplifying. So we have a fraction to the power of 2. That's the same as squaring the numerator and the denominator. So I could rewrite that as 2a to the power of 5 all squared over a squared all squared times 3a. Okay, now I'm just going to simplify the numerator. So I have to do 2 squared, which is 4. Then a to the power of 5 squared, I'm going to multiply, so I'm going to get a to the power of 10 over, and on the denominator I have a squared to the power of 2, which is a to the power of 4. Now, because they have a common factor of a to the power of 4, I can actually cancel. So if I take a to the power of 4 from each, this 10 becomes a 6. So this cancels to 4a to the power of 6 times 3a. 4 times 3 is 12. A to the power of 6 times a. We're going to add the powers, a to the power of 7. Now, we also could have cancelled here straight away, here and here, where a squared, we could have cancelled the 5 to become a 3, and then we could have just squared the numerator, okay? So there's sometimes more than one way to do it. And again, as a mathematician, it's whatever you find is the easiest. So then for the simplifying, all of them have an x in common. So I can actually cancel an x from each one. So if I cancel an x here, I'm left with no x's. If I cancel an x here, I'm left with x to the power of 4. If I cancel an x here, I'm then left with x to the power of 2. So I'm going to get 2 plus x to the power of 4 over 4x squared. And I cannot simplify that anymore because none of the terms have a common factor. Even though the 2 and the 4, they share a common factor of 2, the x to the power of a 4 does not. So even though we could cancel these down and simplify them, because the x to the power of 4 is not a multiple of 2, we cannot do that. Each term has to be a multiple of the factor that you're cancelling. So expand and simplify. So make sure when you're multiplying, don't forget the numbers. 2x times 3, 6x, 2x times minus x squared is minus 2x cubed. Minus 4x cubed times 3 is minus 12x cubed. Minus 4x cubed times minus x is positive 4x to the power of 4. So when I simplify, I'm going to put the number with the largest power of x first, so x to the power of 4. Minus 2x cubed minus 12x cubed is minus 14x cubed. And then plus 6x. Okay, and then lastly, we have 2 to the power of x times 3 to the power of x. We need to simplify this. So we can only simplify this if the bases are the same. Here we have a base of 2 and a base of 3. We cannot simplify this. The answer is just 2 to the power of x times 3 to the power of x. That is in its simplest form. If you had 2 to the power of x times 2 to the power of x, we could simplify that because they both have a base of 2. And when we multiply, we add the powers. So we're going to get 2 to the power of 2x because we're adding x plus x, which is 2x. Some of you might like to see it like this first, x plus x, which is 2x. But they have a different base, so we are not allowed to do that. Okay, so now what I would like you to do is to go through the questions. Before you can move on to the extension, you need to make sure that you are able to do the questions that I have highlighted. So you have to be able to do Q, R, U, V. If you get them wrong, you have to do one more. E and F. So I've highlighted them in pink, the last two from each one. So if we have a look at 3A. So 3A. We have 6x to the power of 4 plus 10x to the power of 6 over 2x. Well, the highest common factor of all of these is, in fact, 2x. They're all in the 2 times tables, and each term has at least one power of x. So you can either cancel them like this. If we divide everything by 2, this becomes a 3. This becomes a 5. This becomes a 1, because 2 is the highest common factor. And we can do the same with the x's. If we divide everything by x, that becomes a 1. that becomes a 3, that becomes a 5. So what we're left with, in fact, is 3x cubed plus 5x to the power of 5 divided by, and we're left with 1 times 1, which is 1. So my answer is, in fact, 3x cubed plus 5x to the power of 5. Okay, so when expanding triple brackets, start off with the first two brackets, expand that, and then multiply everything by x plus 3. So I'm going to show you on the next page. So here we have x plus 5 times x minus 2. So I'm going to just focus on these two first and expand them like I normally would. X times x, x squared. 5 times minus 2, minus 10. 5 times x is 5x. X times minus 2 is minus 2x. And I'm going to simplify that. X squared plus 3x minus 10. Now, all I've done is expanded the first two brackets. So that is still multiplied by x plus 1. So what I'm going to do now is I'm going to multiply each term by x. So I'm going to get x times x squared, x times 3x, then x times minus 10. I'm going to write it under it. So x times x squared, x cubed, x times 3x is 3x squared, x times minus 10 is minus 10x. Now I'm going to multiply everything by positive 1. And so 1 times x squared is x squared. And I'm going to write it under the x squared so it's easier to... You could write it here if you want, plus x squared. But I like to write it under so that I can easily collect like terms. Then 1 times 3x is plus 3x. 1 times minus 10 is minus 10. Now what I'm going to do is simplify this to get x cubed plus 4x squared. Minus 10x plus 3x is minus 7x, and then minus 10. So that is the answer for the first one. Now I'm going to do the exact same really quickly on the other two. This time you can multiply the first bracket by 2 if you want, but I'm just going to multiply the double brackets and then multiply by 2 at the end. So I'm going to have 2 bracket x times x, x squared, minus 3 times minus 4, positive 12. Minus 3 times x is minus 3x. X times minus 4 is minus 4x. So I'm still going to get two lots, and I'm going to simplify this. X squared minus 3x minus 4x is minus 7x plus 12. Multiply everything by 2. I'm going to have 2x squared minus 14x plus 24. Now for the last one, I have 2x minus 1 cubed. I'm going to rewrite that as 2x minus 1 multiplied by 2x minus 1 multiplied by 2x minus 1. Again, I'm going to do the same thing where I multiply the first two brackets. So I'm going to get 2x times 2x is 4x squared. Minus 1 times minus 1 is positive 1. Minus 1 times 2x is minus 2x. 2x times minus 1 is minus 2x. That's all multiplied by 2x minus 1. Again, though, I'm going to simplify the first bracket. So I'm going to get 4x squared minus 4x plus 1 multiplied by 2x minus 1. Now I'm going to do the exact same as I did in the first example. Multiply everything by 2x first. So 4x squared times 2x is 8x cubed. 2x times minus 4x is minus 8x squared. 2x times 1 is plus 2x. Now I'm going to multiply everything by negative 1. So I'm going to get negative 4x squared plus 4x minus 1. And then lastly, I'm going to collect like terms. So it's going to give me 8x cubed minus 8x squared minus 4x squared is minus 12x squared. 2x plus 4x is plus 6x, and then minus 1. So here we're going to look at factorising, and what we're going to do is essentially we're going to be putting back into brackets. So basic examples, we look at the highest common factor and we factorise that out. So here we can see the highest common factor of x cubed and x squared is in fact x squared. So I could rewrite that. If I take x squared outside the bracket, x squared times what is x cubed? We know it's x. X squared times what is 1? Is x squared is 1. We can check that we're right when we're factorising by expanding to see that we get the correct expression. X squared times x is in fact x cubed. X squared times 1 is in fact x squared. So we do know that we are correct. Now for the second one, we have a common factor of x, and 4 and 8 are both multiples of 4. So we also have a common factor of 4. So I'm going to take 4x outside. 4x times what is 4x? That is 1. 4x times what is minus 8xy? That's going to be minus 2y. And again, if you're not sure, you can always double check. So a quick recap of factorising quadratics when the coefficient is 1. So the coefficient of x squared, so this is x squared. The coefficient means the number in front of it. We only have 1x squared, so we don't write 1x squared, but this means we have 1. So quick recap, needs to multiply to give you minus 14, add to give you minus 5. So straight away, I have x minus 7 and x plus 2. Now, when we go back to class, I'm going to show you a cheat method to do this in your calculator, okay? So then, if the coefficient of x squared is not 1, you can see here this is a 2, okay? So what we need to do, if this is a 2, we need to do the AC method. So the AC method is, in fact, we have our 2x squared, so our A equals 2, our B equals 5, and our C in this case is minus 12. So we need to find two numbers which add together to give us B, but they multiply to give us AC, and A times C is minus 24. So they need to add to give us 5, but multiply to give us minus 24. The first two numbers that come to my mind is 8 and negative 3. So I'm going to split this up, 2x squared, and instead of writing 5x, I'm going to write plus 8x minus 3x minus 12. Because here, 8x minus 3x gives us 5x. So we've just written it a different way. It still means exactly the same thing. So now I'm going to factorise. I'm going to imagine I put a line down here. And I'm just going to concentrate on the left-hand side. So 2x squared plus 8x, I can factorise out a 2x. And I'm left with x plus 4. So I leave it like this. Then I'm going to do the same on the right-hand side. I can see that minus 3 is a common factor. So I'm going to get minus 3. And then minus 3 times x, and it's going to be minus 3 times plus 4. Now, you know you're correct if you have an x plus 4 and an x plus 4 because they're both the same. So that means now we can rewrite this as, so we have our bracket x plus 4, and then we're going to have a new bracket, and it's going to be what's left over. And we have a 2x minus 3. So 2x minus 3. So our answer is x plus 4, 2x minus 3. Now again, there is a quick way to do this on the calculator, which I can show you, but this is just a recap of last year. Some of you may have done a different method, but this is the AC method. So, another quick recap, difference of two squares. If all the numbers are square numbers, 4 is a square number, x squared is a square number, and 9 is a square number, and you have a minus here, you can automatically factorise by doing the square root of everything. The square root of 4 is 2. Square root of x squared is x. Then you have the square root of 9 is 3. And then you have a plus and minus sign. Again, if you expanded that and double checked it, you would see that you get 4x squared minus 9, because that you would have numbers that cancel. Here we have x cubed minus x. Now, straight away, a common factor is x. So I'm going to take x out, and I'm going to have x squared minus 1. But x squared minus 1, x squared is a square number, and 1 is a square number, and they have the minus in between, which means it's a difference of 2 squares. So I can further write that as 2 brackets, the square root of x squared is x, square root of 1 is 1, and then I have my plus and minus. Okay, so it's really good to check always for difference of squares. So then for this one, we have x cubed plus 3x squared plus 2x. We can see that they all have an x in common, so I'm going to take out a factor of x squared plus 3x plus 2. I can now see that I have a quadratic in the bracket, which I can then further factorise. 2 numbers that multiply to give me 2 but add to give me 3, x plus 2 and x plus 1. Now I would like you to test your understanding of those previous questions, please. So for question 1, factorise completely. We're going to use the AC method again. So we want 2 numbers that multiply to give you minus 12, because 6 times minus 2, and add to give you 1. Automatically, I'm thinking of 4 and 3. So I'm going to have 6x squared plus 4x minus 3x minus 2. Now, I'm going to split it in half and look for the common factors. But I can see that between 6 and 4, I have a common factor of 2 and x, and minus 3x and minus 2. My only common factor is minus 1. So let's give it a go. So common between 6x squared and 4x, I have 2x brackets. 2x times 3x gives me 6x squared. 2x times 2 gives me 4x. For the second one, the only thing they have in common is a minus 1. So if I take a minus 1 out, and then remember I don't write 1, I'm going to have bracket 3x plus 2. Now again, you know you're on the right lines if both of these brackets are the same, which they are. So now I'm going to put them back together, and I'm going to have 3x plus 2, and our new bracket is going to be our 2x, and this is a minus 1. So 2x minus 1. Again, you can double check if you need to. For question 2, we need to factorise this cubic. I can see straight away that they all have an x as a factor, so I'm going to take out factor of x. X squared minus 7x plus 12. I have a straightforward quadratic. 2 numbers that multiply to give me 12 but add to give me minus 7. X minus 3 and x minus 4. Again, you could double check by expanding. This one here, we have a difference of, instead of it being a difference of 2 squares, it's in fact a difference. No, it's a difference of 2 squares. X to the power of 4 is x squared, square rooted. Then I'm going to have a minus 1 and x squared plus 1. Now, for the last one, factorise completely, is in actual fact... Oh, wait there. We missed a step on this one here. X squared plus 1 I can leave, but x squared minus 1, that's also an extra difference of 2 squares, which is going to give me x plus 1, x minus 1, and then I'm going to have the x squared plus 1, and that's fully factorised. But if you got to this step here, that's a really good step. But watch out again for these difference of 2 squares. For x cubed minus 3, this is actually the difference of 2 cubes, because minus 1 cubed is in fact minus 1. Now, there is a rule for this, which you do not know, but the rule is x cubed minus y cubed, because they're both cubed numbers, equals x minus y, x squared plus xy plus y squared. So in our case, we're going to have x minus 1, x squared plus x plus 1, and that is fully factorised. So to prove that x to the power of a half is actually the same as the square root of x, okay? Well, the square root of x times the square root of x equals x. We know that as a fact. So that should mean that x to the power of a half times x to the power of a half should equal x. X to the power of a half times x to the power of a half equals x to the power of 1, which is in fact just x. Because when we multiply indices with the same bases, we add the powers. So, evaluate 27 to the power of minus a third. 27 to the power of minus a third. Step 1, how do we get rid of the minus? We do the reciprocal of 27. Which becomes 1 over 27 to a power of a third. You can see we've got rid of the minus, we've done. To get rid of this minus here, we do the reciprocal of the number, so we get 1 over 27, okay? To the power of a third. Now, if to the power of a half is a square root, to the power of a third is a cube root. So we actually want to cube root 1 over 27. That's the same as writing the cubed root of 1 over the cubed root of 27. So I'm going to get 1 over 3. The reason why we're evaluating it is because we have to show the steps. Of course, you can put it into your calculator and double check you're correct. Next one, evaluate 32 to the power of 2 over 5. 32 to the power of 2 over 5 can be written as the fifth root of 32, all squared. Whatever the denominator is what we put the root to, and whatever the numerator is what we square, is what we put to the power of. So, the fifth root of 32 is 2, and then we need to do 2 squared, which is 4. If you do not know these from the top of your head, you can use your calculator to work out the fifth root of 32, but it is something that we will need to work on, okay? Mental arithmetic is really important. In Pure 1, realistically, you should be able to do the whole of Pure 1 without a calculator, okay? In the UK, that's how they teach it. Pure 1 is non-calculator paper. Nearly everything we can do is non-calculator in Pure 1. We don't need a calculator for. So it's really good to get our mental maths up and running. Take 2. So we have 1 over 9 to the power of a half is the square root of 1 over 9, which is plus or minus 1 over 3. X to the power of 6 to the power of a half is x to the power of 3, because we multiply the powers. And we're going to get y to the power of a half. Next one says evaluate 27 over 8 to the power of minus 2 over 3. Now, to get rid of the minus, we do the reciprocal. So that means we're going to have 8 over 27 to the power of positive 2 over 3. Then, to the power of 2 over 3 means the cubed root of 8 over 27, all squared. Because remember, the denominator is what we root it, and the numerator is then outside the bracket. Now, we should be able to do the cubed root of 2. The cubed root of 8 is 2. Squared is 4. The cubed root of 27 is 3. Squared is 9. Now, a bit of a fun fact. The reason why when we do the cubed root of 8, we don't have a plus or minus, is because the only way to get 8 is to do 2 times 2 times 2. If we did use minus 2 times minus 2 times minus 2, we would in fact get negative 8. Negative times a negative is a positive, times a negative is a negative. We only ever write plus or minus when we have a square root or a root 4 or a root 6, because we want an even number. Okay then, for the last question, if b equals 1 over 9a squared, determine 3b to the power of minus 2. This is just substitution. Instead of writing b, we're going to substitute in this expression into b. So we need to follow our laws of indices and BIDMAS. So we're going to get 3. Whenever we substitute, we put a bracket. Instead of writing 1 over 9, is everyone happy if I write a squared over 9? It means exactly the same thing. Okay? To the power of minus 2. Now, 1 over 9 a squared is the same as saying 1 over 9 times a squared. We know when we multiply fractions, we multiply the numerators together, because this is essentially over 1. So I'm going to get a squared. 1 times a squared is a squared. 9 times 1 is 9. This is why I can write it like this. Okay? So I'm going to get 3 lots of a squared over 9 to the power of minus 2. Now, to get rid of the minus, I have to do the reciprocal. So that's going to give me 3 lots of 9 over a squared to the power of 2. Then I'm going to square inside the bracket first before I multiply anything by 2. So I'm going to get 3 lots of 81 over a to the power of 4, because I'm squaring, which is also the same. 3 lots of 81, 160, 243 over a to the power of 4 is the final answer. Or some people might like to write 243a to the power of minus 4. Both of those are completely acceptable because they are equivalent. Okay, in the last question it actually says kb to the power of n, so this is the only one they'll accept for the full mark, because they do not want it as a fraction. And we know that over a to the 4 is a to the negative 4, okay? The rules are up here. You need to learn them if you do not know them already. Okay, moving on. Surds, nice and easy, okay? It should take you a few minutes. This is a recap. So, very quickly, root 3 times 2 is 2 root 3. 3 root 5 times 2 root 5. 3 times 2 is 6. Root 5 times root 5 is 5. So that's 6 times 5, which is 30. Root a equals root 4 root 2. Root 4 is actually 2 root 2. Root 12 plus root 27. Well, root 12 can be broken down into root 4 root 3, because 3 times 4 makes 12. 4 is 2 root 3. Root 27 can be broken down into root 9 root 3, because 3 times 9 is 27. Root 9 is 3 root 3. So I've got 2 root 3 plus 3 root 3 is 5 root 3. Then for the last one, it's exactly the same, but I am just going to change this root 8 to get... No, I'm not going to change the root 8. I'm just going to expand it out like I normally would. Root 8 times root 2 is root 16, which is 4, but I'll simplify that in a minute. 1 times minus 3 is minus 3. 1 times root 2 plus root 2. Root 8 times minus root 3 is minus 3 root 8. Root 8, though, as we know, is 2 root 2. Okay? So root 16 is 4 minus 3 plus root 2 minus 3 lots of, and remember, root 8 is 2 root 2. Okay? So 3 lots of 2 root 2. 4 minus 3 is 1. 2 root 2 minus, these two are going to be 6 root 2. multiplied. Root 2 minus 6 root 2 is minus 5 root 2. That is our final answer. This is just a quick recap, and this is what we should be fairly happy with from GCSE. So, what I would like you to do is, I'm just going to highlight this. You could just do this one for homework, this question here. The answers are on the next slide. Those of you who are really confident with this, can you try the challenges for me, please? And for homework? Okay. So then, rationalising the denominator. Again, this is just a quick recap. Root 5 times root 5 we know will give us 5. Rationalising the denominator means making sure that the denominator is an integer. We do not want it to be a square root of a number. So to get rid of the square root, we multiply it by the square root. But we have to multiply by a number which doesn't change the original number. If I had 7 and I multiplied that by 1, I still get 7. If I had 426 and I multiplied that by 1, I still get 426. Any number I multiply by 1 is going to give me that number. The number 1 can be written in many forms. For example, 7 over 7 equals 1. 426 over 426 equals 1. Love heart over love heart equals 1. Anything over anything equals 1. Anything multiplied by 1 equals what it was. So, using that theory, we can multiply this by root 2 over root 2. Because root 2 over root 2, if the numerator is exactly the same as denominator, it equals 1. Using rules of multiplication, on the numerator we're going to get 1 times root 2, and on the denominator we're going to get root 2 times root 2. 1 times root 2 is root 2. Root 2 times root 2 is 2. So, very quickly, test your understanding. You've got 3 questions to do. Off you go. So, 3 over root 2. Yes, I'm going to multiply that by root 2 over root 2. Okay? Yeah. So we're going to get 3 root 2 over root 2 times root 2 is 2. So there's the answer. So then for the second one, we're going to get 6 root 3 over 3, which is going to cancel to 2 root 3. For the next one, we're going to get 7 root 7 over 7, which is just going to give me root 7. Then I'm going to have 15 root 5 over 5 plus root 5. 3 root 5 plus root 5 is 4 root 5. Again, I've done these really quickly because this is the speed we should be able to get into. Okay? For the test your understanding, we're going to multiply by root 3 over root 3. So I'm going to get 12 root 3 over 3. 12 root 3 over 3 is actually 4 root 3. I'm going to multiply by root 6 over root 6, which equals 2 root 6 over 6. 2 over 6 is actually root 6 over 3. Because we're cancelling the fractions, the numbers. 4 root 2 over root 8. Root 8 can be written as 2 root 2. So I'm going to multiply by 2 root 2 and 2 root 2. You can multiply just by root 2 over root 2 if you want, but a lot of people like to multiply, so we're going to get 4 times 2 is 8 times 2 is 16. Over 2 times 2 is 4 times 2 is 8 16 over 8, 2. So when we're rationalising the denominator, the examples we just looked at had just one square root. Okay? This one has a square root plus a number. To get rid of this, what we do is we multiply by exactly the same as whatever's on the denominator, except we change the sign. That was a plus, now it's a... Whatever is on the denominator, we have to put on the numerator so that they're the same on the top and the bottom, the numerator and the denominator. The reason why we want them the same on numerator and denominator is because that will equal 1. And if we multiply any number by 1, we're not changing that number. And that's all we're doing. Sometimes, for example, if we had x squared plus 4x, we can factorise this. They have a common factor. This is the same as x bracket x plus 4. They mean the same thing. They're completely equivalent. They're written two different ways, aren't they? That's exactly what we're doing with these numbers here. For example, the number 6, I could also write as 3 times 2. They are equivalent. They mean the same thing. They're just written slightly different. That's all we're doing. We are writing these numbers without a surd on the bottom. And the surd is this square root. We do not want a square root on the bottom. Okay, on the denominator. And we really need to get used to these words, denominator and numerator. Okay? So, on my numerator, I need to multiply 1 times root 2. And I'm going to write it like I would all the steps. That's what I would normally write. Then on the denominator, I'd write root 2 plus 1, root 2 minus 1. Then from there, I would expand. 1 times root 2 is root 2. 1 times minus 1 is minus 1, all over. Then I'm going to have root 2 times root 2, which is 2. I'm going to have 1 times minus 1, minus 1. Then I'm going to have 1 times root 2 is root 2. And then I'm going to have root 2 times minus 1 is minus root 2. Now you will notice the reason why when we multiply it, we change the sign, a plus to a minus, is because of a difference of 2 squares. Okay, a difference of 2 squares will ensure that we cancel out these 2 here. It's quite a nice trick. So they're going to cancel, plus root 2 minus root 2. It will always happen. So then our answer is going to be root 2 minus 1 over 2 minus 1 is 1, which is just going to give me root 2 minus 1. So we have a few more examples to do. So again, I'm going to multiply this by root 6 plus 2, root 6 plus 2. This is going to give me 3 bracket root 6 plus 2 over root 6 minus 2, root 6 plus 2, which is going to equal. Now, for those of you who want an easy way, you only need to do root 6 times 6 and minus 2 times plus 2 for the denominator, because you know they're going to cancel. So you're going to get 6 minus 4 as the denominator. Because you're going to have root 6 times root 6, which is 6, minus 2 times 2, which is minus 4. Then you're going to have minus 2 times root 6 is minus 2 root 6. Then you're going to have 6 times positive root 2 is 2 root 6. 2 root 6 minus 2 root 6 is 0. So you never really have to do that one. If you want to do that one, you can. Then on the numerator, I'm going to get 3 root 6 plus 6. 6 minus 4 is 2, so I'm going to get 3 root 6 plus 6 all over 2. Okay? Now, to truly simplify this, I need to split my fraction. So I'm going to get 3 root 6 over 2 plus 6 over 2. Now, that 6 over 2 cancels to 3. So my final answer is going to be 3 root 6 over 2 plus 3. Okay, so can you give these 3 questions a go? So you have 1, 2, 3. Try and give them a go. So I'm going to explain this really quickly, but it's simple. It wants us to convert this into the form root 3 to the x. What we notice here is root 3 is the base, so we need to convert the 9 and the 27 into bases. We know the rule is root a to the x is the same as writing a to the 1 over x. Using that rule, I'm just going to rewrite. I'm not sure what happened there. 9 to the power of a quarter over 27 to the power of a fifth is equivalent to 3 to the power of 1 over x. Now, we need them all in the same base. We're going to put 3 as the base. 9 is the same as saying 3 squared. And whenever I substitute, I'm going to put in a bracket. 27 is the same as saying 3 cubed. That's going to equal 3 to the 1 over x. Now, 3 squared to the power of a quarter, I can rewrite that as 3 to the power of 2 over 4, which we know is a half. I'm just going to keep it in quarters a second. And then I'm going to get 3 to the power of 3 over 5. This is a division, isn't it? So I'm going to get 3 to the power of a half divided by 3 to the power of 3 over fifth, which actually means I'm going to subtract the power. What's a half minus 3 fifths, please, Guida? Negative 1 over 10. That is 3 to the power of 1 over x. So in this case, our x equals negative 10. Because what we want is for these two powers to be equivalent. Okay?